Today we will be simplifying rational expressions. And so when we do this, we need to always think of factors as we simplify. We can't just cross off the x's here, or even the 3 and the 15, because it's not really 3 on top. It's 3 more than x. And so we always need to have factors. Factors are numbers that multiply. Well, up on top, we can't factor this. X plus 3, there are no factors of this because this is just one number. We just don't know what x is. But on the bottom of the fraction, we can factor it. So I'm going to rewrite the problem, x plus 3. But instead of writing the x squared minus 2x minus 15, I'm going to factor it as two binomials. And so I'm going to start with x and x making x squared. Now numbers that multiply to make negative 15 would be like 5 times 3. And those do subtract to make the negative 2 if I put the minus sign with the 5 and the plus sign with the 3. So at this stage, now we can do some reducing. So simplifying means make it easier to understand, less terms involved. And here I can cross out those x plus 3's, leaving us just with a 1 on top of the fraction, because x plus 3 over x plus 3 just makes 1. So all I've got left is the 1 on top and the x minus 5 on the bottom of the fraction. And that's our answer. So again, the key is to always factor and look for factors. So for instance, on this next one, there's a common factor between these two terms. I can divide both of these numbers by 3, so I can take out a 3 from each of them. And so when I do that, I'm going to rewrite that 3, and then I do the division, and I've got 3x over 3 makes x. 6 over 3 makes 2. So that's my first part. Now down below, this is a trinomial. If it factors, it's going to have two binomials. And the way it factors is x and x make the x squared. Numbers that multiply to make 2, well, there's only one option, 2 times 1. And to add to make 3, we make them both plus signs. So from that point, we can go ahead and take out those common factors. X plus 2, those will cross off. And so what we've got left is just that 3 over x plus 1. And that's our answer. Well, the next one is similar to the first in that there's no common factors between the x and the 6. So all I have to do is rewrite what I've got there and then factor the denominator. Now, numbers that multiply to make a positive 6, but they add to make negative 7 would be a negative 6 and a negative 1. And then from there, we can go ahead and take out those common factors. So the x minus 6 is canceled. Remember, 1 is left on top. So our answer is 1 over x minus 1. Now, a lot of people want to cross off these 1's, but you can't do that because it's not really 1 on the bottom. It is 1 on top, but not 1 on the bottom. This just means 1 less than x. That's what that expression represents. Well, the next one, we have a little bit more factoring that we can do up top. This is a difference of squares. So oftentimes on these problems, you will see those differences of squares. Now, differences of squares always end up factoring as a sum and a difference. And so when we factor this, we're going to have two binomials. And it's going to factor to an x and an x to make the x squared. Now, to make the negative 49, we're going to have a negative 7 and a positive 7. Now, down below, we have two binomials. Now, numbers that multiply to make 7 would be 7 and 1. And they do add to make 8 if we make them both positive. And so from that point, we can now cancel out those common x plus 7's. Those will cancel. We're left with only an x minus 7 on top and an x plus 1 on the bottom. Now the next one, we've got two trinomials. And so when we factor this top one, we're going to look for numbers that multiply to make 5. We don't have a whole lot of options, just 5 and 1. They have to subtract to make 4. So if they're going to subtract to make positive 4, we're going to make the 5 positive, the 1 negative. Down below, we've got two binomials. And numbers that multiply to make 3 but add to make negative 4 would have to be a negative 3 times by a negative 1. And then from that point, we can now take out those x minus 1's. So we're left with that x plus 5 on top. And we've got the x minus 3 on the bottom of the fraction. There is our answer. Well, this next one, we've got some common factors here. So we look at those two terms. I see x goes into this first one and x goes into the second one. So that's what you have to take out. So sometimes you have an x squared, but it doesn't factor as two binomials, sometimes only one, depending on what all the terms are. Here they had a common factor of x, so I just took out that common factor. And see, if you multiply back, x times x makes the x squared. X times negative 2 makes the negative 2x. So it does end up working. Down below, we've got a trinomial. Now, this will factor as two binomials because there's no common factors. So if it does factor, we're going to have x and x making the x squared. Numbers that multiply to make negative 8 are going to be like a 4 and a 2. Now, to get it to be a positive 2, we need a positive 4 and a negative 2. And then from that point, we can cross off those common factors of x minus 2. So what's left over? Just an x on top and an x plus 4 on the bottom of the fraction. So again, the common mistake is people want to cross off these x's, but you can't do that because it's not really x on the bottom. It's 4 more than x. It is x on top, but not on the bottom. Well, let's take a look at this next one. Here we have a trinomial on top. So we'll just go ahead and factor that. So it factors to an x and an x, making the x squared. Numbers that multiply to make 12, 4 and 3. To subtract to make negative 1, let's make the 4 negative, the 3 positive. From there we've got a 4 minus x. Now here's the problem. Looking at this 4 minus x, it's not the same as this one. See, here the 4 is negative, here the 4 is positive. Here the x is positive, here the x is negative. You cannot cancel them because they're not the same. So what we need to do is take out a common factor. We can take out a negative 1 from each of these because they both have the same number but just opposite in sign with both of them. So since they both are the wrong sign to be able to cancel, that's what we're going to do is take out that negative. So let's rewrite what we've got. I've got the x minus 4 and the x plus 3. That hasn't changed. But down below now, we now have a negative 1, and I'm going to switch the numbers around. See, it becomes a positive x because these two negatives cancel, and it becomes a negative 4. And so from there, we can go ahead and reduce. So the x minus 4s, they cancel out, so we're left with this x plus 3 on top with a negative 1 on the bottom. So negative x minus 3 is our answer. So let's take a look at the next one. On the next problem, we've got a similar situation where we've got the 5 and then minus 5x. So you see, same thing over here. We had a 4 minus x. When your leading term is the constant and the next term, the x term, is negative, you're going to want to take out that negative. And that's what I'm going to do on this problem as well. So I'm going to go ahead and take out this 5, that's a common factor, but I'm also going to take out a negative 5. And then what I'm left with is the x, and negative 5x over negative 5 makes just an x. 5 over negative 5 makes negative 1. Down below, it's a difference of squares. So just like this one up here, where it was x squared minus 49, difference means subtraction. That's what we have here. And x squared and 1 are perfect squares. So it will factor as a difference, x minus 1, and a sum, x plus 1. And you see the negative 1 and 1 make the negative 1, and the outside and inside terms cancel out. And what happens here is we go ahead and take out these x minus 1s. They're gone. We're left with a negative 5 over x plus 1 as our answer. So common mistake is people won't take out the negative. And if they don't, you cannot do the reducing because they're not exactly the same. They need to be exactly the same in order to cancel. Same sort of thing here. Notice how we have 27 as the leading term. I want the x squared as the leading term. So I see a common factor, and I'm going to go ahead and take that out. I see 3 goes into the numbers, but I'm going to take out a negative 3. And take out a negative 3 here as well. So pull out that negative 3, redo the problem here, do the division. We've got x squared minus 9. So you see how 27 divided by negative 3 makes the negative 9. Down below, I see 6. Divide the whole thing by 6, every number there. And so take out a 6, it'll make it easier. So what we have left is x squared minus 6x plus 9. And so now we can do some reducing, but then we can also factor further. So you see how we have a difference of squares again. X squared minus 9, that factors. And so let's go ahead and rewrite what we've got. Negative 3 factors to an x minus 3 and an x plus 3. Numbers that multiply to make negative 9, subtract to make 0. And down below we got that 6 still, and we got an x minus 3 and an x minus 3. Numbers had to multiply to make a positive 9, but subtract to make, or actually add to make negative 6. So now we'll do some reducing. So I see the x minus 3's, those will cancel. Now again, these are not the same, and the x's are the same, but the 3's are not. So I cannot reduce, I cannot take out a negative, because they will never be exactly the same. But I can reduce this 3 and the 6. So the 3 will be taken out because we'll divide by 3. Here I'll divide by 3, I'm left with 2. So what's left over? Got this negative sign, so negative 1 times by x plus 3. And this is all over 2 times by x minus 3. And I'll just leave my answer in that factored form just like this. And there it is. So those are the types of problems you'll see on tonight's homework. Good luck.